Now let's look at how the proxy is structured. Just as in the real-world example with the beekeeper, a proxy in a software application acts as a go-between between a resource, here represented as real service, and a client. Typically, the proxy will mirror the interface of the real service. If the client needs a different interface, you should look at something like the adapter design pattern instead of the proxy. When the client makes a request to the proxy has an opportunity to perform any logic needed before forwarding the request on to the real service. In some cases, it may not choose to call real service at all. Maybe the client doesn't have permission to access the real service, or maybe using the real service is expensive from a resource standpoint, so proxy only calls it periodically and otherwise caches the result and just uses that. After calling the real service, the proxy might do additional work before returning the response too. If it's acting as a cache, this is when it would keep a copy of the response. Sometimes the proxy won't have enough information to restrict access to a resource until it has the resource itself, so some protection logic might occur after the request has been made. In any case, even if the proxy restricts access to the real service, it will still need to return some kind of a response to the client. And importantly, the client should be completely unaware of whether it is working with the real service or with a proxy. The basic structure for the proxy design pattern is to create a new proxy class that implements the same interface or base type as the real service. The proxy then calls out to the real service. In the case of a remote proxy, this call may be across process or often even network boundaries, but in other scenarios it's often just an in-process method call. Remember, the client should not be aware that the proxy is involved. One of the reasons for using the proxy pattern is to keep the client ignorant of the details of how it is accomplishing its task. We can leverage polymorphism because both the proxy and the real service implement the same interface, and the client should depend on that interface. At the end of the day, the client just wants some honey. It shouldn't need to change based on whether that honey is accessed directly from the hive or with the help of a beekeeper or from a mail order service. As long as honey is obtained as the result of the operation, the client is satisfied and none the wiser. An alternative structure for using the proxy has the proxy inherit from the real service. This approach still leverages polymorphism, and the client will still have a dependency on the real service, but instead will get the proxy. However, this approach is less desirable because it is a less flexible design. It is a bit simpler, and it will work in many scenarios, especially if you don't have the ability to modify real service so that it inherits from a new common interface or base type. However, this approach does require that real service has marked any necessary methods or properties that you're going to use as virtual, so that the proxy can override them.